Hello, in this video I'm going to solve problems in homework 2. The first question, we want to calculate this number and put the exact value here. And of course the calculator is not allowed. Okay, how can we do that? So let us start doing these things separately. So of course -8 is already -8. I don't need to do anything with that, so I will start from here. So -2, 1/2 to the power of 3. How can I simplify that? So you have to calculate this. Be careful. When you say -2, 1/2, this means what? It means that whatever this number is, you multiply it by a minus sign. So that 1/2 is actually 5/2. So what I have a minus sign, so the answer becomes -5/2. Don't think, some people think that they have to multiply 2 by -2, -4, and add 1 to it, it becomes -3, and then write -3/2. So be careful, this is not the correct one. Okay? So what we do, I continue. As I told you, I consider 2 1/2. And then the answer becomes 2 times 2, 4 plus 1, 5/2. But I have a minus sign, so I put the minus sign there, and then I have to the power of 3. Okay? But because this is minus and this power is odd, it remains minus. And then what can I do? I can raise the numerator to power 3 and the denominator to power 3. Why? Because of this formula, that if I have a over b to power n, I can write a to power n over b to power n. So that's one of the famous formulas in powers, yes? So I will do this. I put the minus sign here because this is odd, and then I would write 5 to the power of 3 divided by 2 to the power of 3. But that is very easy. I put the minus sign here. 5 to power 3 means 5 times 5 times 5. If you do that, it becomes 125. And then 2 to the 3 means 2 times 2 times 2, which is 8. So that is the answer to the first part. Okay? Now I go to the next one, 0.25 to the power of 2. So one thing that I want to mention is that be careful, differentiate between this dot and that dot. You see, one dot is higher, one dot is lower. The lower dot is the decimal point, because in Swedish you put comma, but in English you put dot. Then you have to be careful not to confuse this dot with that dot. This dot, which is a little bit higher, is multiplication, but this dot, which is a little bit lower, is decimal point. Okay, if I want to work with the decimal points, it is not that easy, because then it means that I have to multiply 0.25 by 0.25. It's always recommendable, preferable to work with fractions. So here, instead of 0.25 squared, what is 0.5? 0.5 is 1/4, and then I raise it to power 2, so this becomes 1 to power 2 exactly because of the same rule, and then 4 to power 2. But 1 to power 2 is 1, 4 to power 2 means 4 times 4 is 16. So the answer to the second part is 1/16. Okay, let me calculate this one. Okay, here I would first multiply, of course it doesn't matter, but here I prefer to multiply the powers first, using which rule? If I have a to power m and then to power n, the answer becomes a to power m times n. Okay, so what I will do, I would say that -5 to the power of -3 and then to the power of 2. So it becomes -5 to the power of -6. Because if you multiply -3 by 2, it becomes -6. So far, it is not that clear what I'm supposed to do, okay? Because on the other hand, -5 to the power of -6, of course I can write it with positive power. I can write 1 over -5 to the power of +6, and because 6 is even, I know that this minus sign will be cancelled, so I can write it as 5 to the power of 6. Okay, But I am hesitant actually to calculate it now, because 5 to the power 6 means 5 times itself 6 times, which becomes a huge number. But let us keep it and see what happens in the future. Might be there are some things that I can simplify without having to calculate 5 to the power of 6. Okay, this one I will do it exactly like the previous case. First I have 2 and then I have -2. So what will happen? This becomes it becomes 0, 1 to the power of -4. So I'm using the same rule again. I am multiplying these two and I will get -4. Yes? But what happens here? 0.1 is nothing except 1 over 10. So I told you that's always preferable to work with fractions. It's -4. And then if you remember, during the lesson I told you that if you have a fraction to some negative power, you can swap the numerator and denominator and then you put n up there. So here what I can do, I can swap the numerator and denominator and write 10 over 1, and then the exponent becomes +4, but no one writes 10 over 1 because there is a simpler name for it, and that is just 10. So that's 10 to the power 4. So the previous case I stopped here, and here I stop here because I want to see what happens. Might be in combination I can simplify more. Okay, now what I can do, I can start with the question mark is equal to. So the first thing is -8. So let me put it in place. -8 multiplied by. Second one, do you remember? Now I stopped there, but now that 5 to the power 6 appears, it becomes clear to me that it is not a good idea to write 5 to the power of 3 as 125. It is better to keep it like that. Okay? So what I will do, I will write minus, and then instead of 125 I go one step backward, which was not easy to see from the beginning, but now I write it like this. But it is good to write 8, because the 8 that I will write here will cancel that 8, so it is better just to write 8. So you have to be flexible. Okay, not everything is clear a priori, so you have to do some calculations and change your strategy accordingly. Okay, now what we go to this one, which is that one. Yeah, because 1 over 16 is not a big deal, so let me just write multiplied by 1 over 16. And then now when I go here, I have this number. Okay, so 1 over 5 to the power of 6. And then finally, because of that, I can write 10 to the power 4. Okay, let us now see what we can simplify. So one thing that I can simplify is, first of all, this minus sign and that minus sign, when they are multiplied, they are gone. And then this 8 and that 8 are also gone. But now look, here 5 to the power of 3 and 5 to the power of 6 are simplified, but I have 3 in the numerator. 5 to the 3 means 5 times 5 times 5. And 5 to the 6 means 5 times itself 6 times. So 3 of them and 3 of them gone, and 5 to the power of 3 is still left. Yes. So what happens? It becomes 1 over 16, and then I have 1 over 5 to the power of 3, and then I have 10 to the power of 4. Okay, now what we can do, I can borrow one of these 10s, because I have 4 10s, but I have 3 5s. So what I will do, I would write it 1 over 16, and then I would write 10 to the power of 3 divided by 5 to the power of 3, and then multiplied by an extra 10. But then you see that the same formula, but this time going backward, is applicable here. Yes, because I can write 10 over 5 to the power of 3. But 10 over 5 is easy, it is just 2. And 2 to power 3 is 8. So this number is nothing except 8. Yes? So I would write it here. So if you don't mind, let me continue here. So it becomes 1 over 16 times 8 times 10. and then it becomes extremely simple. Why? Because 8 and 16 are simplified. This is 2, and then 10 and 2 are simplified, so the answer is just 5. So the final answer to this problem is 5. I'm not saying this is the only way, so 5 is the number that you have to write here. I'm not saying this is the only way to do it, but that is one way. And you see that I really didn't need any calculator. And one lesson is that even to me, it was not clear that I shouldn't continue. So you see, when I started solving it, I continued up to this point. But because of what happened later, I realized that was not a good decision. I have to go one step backward. So in solving problem, you have to have this dynamic of thinking, which would be very helpful. Okay? So now we go to the next problem. Okay, now let us solve problem number 2. This relation is given. You are supposed to find the proper value for x so that the left-hand side becomes equal to the right-hand side. Okay, and of course I have provided the hint for you to make it easier for you to think. But of course this is not a very big help. In principle, finding that 0.125 equals to 1 over 8 shouldn't be hard for you. How? For example, 0.125, everyone knows that this is 125 over 1000. Yes, this is something that we know. If you cannot simplify it directly, but immediately you see that this one and that one are both divisible by 5. So you divide the numerator by 5 and it becomes 25, and the denominator by 5 becomes 200. But again, you see that the numerator and denominator both are divisible by 5. So I divide the numerator by 5, I divide the denominator by 5. It becomes 5 over 40, and finally again I know that it is divisible by 5, so it becomes 1 over 8, and that is what you're supposed to find. So that is, I mean, that's not a very big help, but at least it is hinting to, it's guiding you that changing to fractions is a better idea than working with decimal numbers. So by having in mind, I will start doing it. So instead of 0.5, I can write 1 over 2. Instead of 0.125, I can write 1 over 8. And instead of 0.25, I can write 1/4. So let me write this here for you. So this becomes 1 over 2 to the power of x multiplied by 1 over 8 to the power of minus x. And on the right hand side, it becomes 1 over 4 to the power of 2. So what I did, instead of 0.5, I put 1/2, and then I copied and pasted this x here. So you see 1 is the same one as I have written here, but instead of this number, I have used this hint and I have written 1 over 8. And then I copied and pasted this minus x top there. And instead of 0.25, I have written 1/4. And then I have copied and pasted this 2 here. Yeah, nothing. But what is 1 over 8? What is that? It is just simply 8, because this means that this is the inverse of 1 over 8. 1 over 8 itself is the inverse of 8. So if you make a number 2 times, if you find the inverse of a number 2 times, you go back to the same number, yes? So what we will do for this one, what can I do? For this one, I can write 1 to power x, 2 to power x. But 1 to power x is just simply 1 and then 2 to the x. So instead of this expression, I just simply write this, yes? Okay, so it becomes 1 over 2 to the x multiplied by 1 over 8 is just simply 8, and then I have to power minus x. And on the right hand side, what do I have? I have 1 over 4 to the power of 2. But 1 over 4 to the power of 2 is 1 to the power of 2, which is 1, divided by 4 to power 2, which is 16. But you see that I don't want to guess. I want you to derive what x is. So one idea is to do what? For example, this one I can bring it down and make it positive power. So what I would write 1 over 2 to the x times 1 over 8 to the x is equal to 1 over 16. But you know that if I have a fraction, another fraction, I want to multiply them. I multiply the numerators and I multiply the denominators. So 1 times 1 is just simply 1. And then what do I have? I have 2 to the x multiplied by 8 to the x is equal to 1 over 16. But do you remember this formula? We have a to the power of m times b to the power of m. So whenever I have two powers and I want to multiply them, if the exponents are the same, what do? I multiply the bases and then write the exponent. Okay, so 2 to the x multiplied by 8 to the x, I can do the same. I can multiply the bases and I can write the exponent. But 2 times 8 is just 16, so it is 16 to the x. So this means that instead of this expression, I can just simply write 16 to the x. So it becomes 1 over 16 to the x is equal to 1 over 16. On the other hand, I have one fraction on the left, I have another fraction on the right. They are supposed to be equal. The numerators are already equal. This equality cannot hold unless the denominators are also equal. So I can conclude that the denominators should be the same. But isn't it, you see that we derived what x is. X is a number, so that 16 to that number becomes 16 itself. Nothing changes. So of course, what x is? X is 1. And that is the answer to this problem. So what you are supposed to type is just 1, because as you see, x equals 2 is already typed by me. Okay? So now we go to the next problem. Okay, now let us solve the last problem, number 3. Consider the following number. If you write this number as a single power with base 16, then the exponent is equal to what? Okay, my point of writing this problem was to teaching you that sometimes factorizing big numbers is helpful if you want to simplify a fraction in which multiplication and division and power are the only operations involved. It doesn't mean that if you sit down and think better than I do, you will not be able to find any other way or even some shortcut. Okay? But my goal of this exercise is to teach you something else, that in the worst case scenario, you can always use factorization in the way that I want to tell you and simplify this expression. Okay? So for example here, let me follow this strategy. So I will factorize 120. Of course you can factorize 120 by 260, then by 230, then by 215, then by 35, then by 51. Yes, this is one way, which of course is correct, but it is also good to see that 120 is 12 times 10, but you already know the factorization of 12, because 12 is 4 times 3 and 4 is 2 to the 2 times 3. So it makes it faster, okay? And then 10 is 2 times 5. No, it's factorization, but because 2 appears here and there, you combine them and then write 2 to the power of 3 times 3 times 5. So that's the factorization of 120. Again, for 80, you can of course do it the normal way, but you can also see that this is 8 times 10. If I ask you what 8 is, you will tell me 2 to the thirds, yes, and then times 10. 10 is also 2 times 5, but 2 to the third and then times 2 is 2 to the fourth, and then I have times 5. So that is the factorization of my 80. And this is actually a little bit bigger number here, so 20 is 2 times 10, and then 10 is 2 times 5, so it becomes 2 to the 2 times 5, or even simply 4 times 5, and 4 is just 2 to the 2 times 5. Okay? And then even 6 can be factorized. 6 is factorized by 2 and 3, so 2, 3. And then 0.25, by the experience that you have so far, it's better to write it as 1 over 4, but 4 can be factorized to 2 to the power of 2, so let me bring it up. It becomes 2 to the power of minus 2. And for the last one, 2 over 3 to the power of 16, what can I do? I can write 2 to the power of 16 divided by 3 to the power of 16, but let me bring 3 to the power 16 up. The price that I have to pay is to make it negative. Make sure that all these calculations that I made here is reasonable for you. You understand that. Otherwise, please let me know so that I can help you with them. Okay, so now what I will do, I would say that the question mark that I am looking for, instead of 120, I put this number, but remember that I have an exponent up there, so this becomes 2 to the 3 times 3 times 5 to the power of 11, multiplied by 80 is this expression, but you also have a power of minus 4 up there, so this becomes 2 to the 4 times 5 to the power of minus 4. And then instead of this expression, I can simply write this, so it becomes 2 to the 16 times 3 to the power of minus 16 all over. In the denominator I have 20 to the power of 7. What was 20? 20 was this one, so this becomes 2 to the 2 times 5 to the power of 7, and then 6 is just simply 2 times 3, and I have a power of minus 5 there, so it becomes 2 times 3 to the power of minus 5. And then finally, instead of this expression, I can write 2 to the power of minus 2, but remember there is another minus 2 there, so it becomes 2 to the power of minus 2 to the power of minus 2. But then if you see, everything is either base 2 or 3 or 5. Okay? But which formula is now suitable? Two formulas, yes? So I think I can fit them here. So one formula tells you that if you have a product and if you want to raise it to some power, you can raise each one of those separately to that power and then multiply it. Another formula tells you that if you have a power and you want to raise it to another power, you put the base and you multiply the exponents. Okay, so here I want to do this here. First, I see that I have the product and I have a power, so I have to raise this one to power 11, this one to power 11, and this one to power 11. These two to power 11 is not a big problem, so what happens? It becomes 3 to the power of 11 times 5 to the power of 11. But this time, this is 2 to the power of 3 to the power of 11. Now I use this rule, so it becomes 2 to the power of 33. So you can do all these things in your head, okay? So 2 to the power of 33. The next ones I don't explain that much, so again, this one becomes 2 to the power of 4 times minus 4, which is 2 to the power of minus 16 multiplied by 5 to the power of minus 4, and then I copy and paste 2 to power 16, and then 3 to the power of minus 16, and then all over I will do the same thing for the denominator. So this becomes 2 to the power of 14 because 2 and 7 will be multiplied. Yes, and then times 5 to the power of 7. The next one becomes 2 to the power of minus 5 times 3 to the power of minus 5, and the next one is this power of minus 2 will be multiplied here, so it becomes 2 to the power of positive 4. Okay? You can do a lot of things here, but let me be patient. And then you see that this 2 to power 33 times 2 to power minus 16 and 2 to power 16. So you see, because the bases are all the same, I have to add the exponents. But when I add 16 to minus 16, that is gone, so only 33 survives. So in the numerator, I will have only 2 to the power of 33. What about 3? 3 appears here with exponent 11. And 3 appears here with exponent minus 16. The bases are the same. I am multiplying them, so I write the base and then I add the exponents. The exponent here is minus 16 and 11. If I add them, 11 plus minus 16 is actually minus 5. But there is also one more, and that is the base 5. So 5 to the 11 multiplied by 5 to the power of minus 4. The bases are the same. So I write the 5 here and I add the exponents. 11 plus minus 4 is 7. Okay? In the numerator, I cannot go forward more than this. I will do the same thing in the denominator, but let us do it a little bit faster here. So you see 2, 2, and 2. I have 14 minus 5 and 4. The bases are the same. I add the exponents. 14 minus 5 is 9 plus 4 is 13. So it becomes 2 to the power of 13. Yes, multiplied. What about 3? 3 is alone, by the way, so I just copy and paste that one. 3 to the power of minus 5. And what about 5? 5 is also alone. Very good. Okay, so you see it's very simple now, because 5 to the power of 7 and 5 to the power of 7 are gone, and 3 to the power of minus 5 and 3 to the power of minus 5 are also gone. So what is happening here? I want to divide two powers with the same base with different exponents. So you know the rule. What the rule is? Let me write here. A to the power of m divided by a to the power of n. So you write a to the power of m minus n. So let me separate them so that you are not confused, even though the color is different. Okay, so what happens here? I would write 2 to the power of 33 minus 13. So this becomes 2. Sorry, let me change my color. So 2 to the power of 20. But be careful. The problem is asking you if you write this as a power with base 16. This is one single power, I agree, but the base is 2. So how can I make it base 16? Okay, so instead of 20, I can write 4 times 5, but this can also be viewed as 2 to the power of 4 to the power of 5. But 2 to the power 4 is nothing except 16, and I put 5 there. So you see that this answer is of course correct, but the base is not 16. Using this trick, I wrote the same number as another power, but this time the base is 16. And then I am supposed to type the exponent here, and then immediately it becomes clear that the exponent is 5. Yes, so what I have to type is just simply 5. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.